Warm greetings to all. We introduce before you our final year project MOTOBOT, the self-balancing motorcycle using the concept of reinforcement learning, guided by Assistant Professor Rinu George, and our team members are Anjana P, Mariya Paul, Mushtaq Sakkeer, and myself Malavika Girish. MOTOBOT, an electric-driven robotic motorcycle that learns to balance itself using reinforcement learning algorithm. It is able to stabilize itself against any impact and can move along a particular path in both directions. It could serve as an ease of transport for physically disabled people. Riding a motorcycle is considered to be a fairly simple task, but it's an issue for people suffering from developmental disabilities. Despite the features and popularity of motorcycles, they lack safety and are very risky. Hence, motorcycle accidents are fatal. In order to overcome the previously shown scenario, we have designed a 3D prototype which was then simulated in the 5-leg simulator. We have created an environment called Balance with the required packages, and the model was trained to balance itself in the environment. The properties like the weight of the frame, the momentum wheel were calculated a dozen times and simulated each result. These are the output parameters obtained during training, and our aim is to maximize rewards. After successful training, the test results proved that our model was able to balance in both forward and backward directions. We have used 3 sliders for adjusting driving velocity, steering angle, and steering force. By inputting a negative value to the driving speed parameter makes the motorcycle move forward. Similarly, the motorcycle could take turns by adjusting steering parameter. As the driving speed takes positive value, motorcycle moves backward. The model was able to move along a slope in both directions. The motorcycle frame was printed at Fab Lab Kochi. The material used for printing is PLA, and each part was printed separately with 50% infill. The inertia wheel was CNC machined out of aluminum weighing 150 grams. Initially, we tested the working of the inertia wheel alone. The gyroscopic sensor was attached to the center of the frame, which can sense every minor tilt of a vehicle. The successfully trained simulation model was implemented in the real hardware using Raspberry Pi board. Balance is achieved using the reaction wheel placed at the center of the motorcycle. The speed of the reaction wheel is increased or decreased to generate a reactionary torque above the spin axis, which is parallel to the motorcycle's frame. As the motorcycle begins to fall to one side, the motor mounted to the inertia wheel applies a torque on the reaction wheel, generating a reactionary torque on the motorcycle, which brings back the motorcycle balanced. This is how the implemented hardware moves forward in real world. Similarly, the backward motion. Along a slope and hump. On a rough surface.
demonstrates the remarkable use of balancing the motorcycle for those people whose concern is safety and people with certain disabilities. It can be used as an alternative way for transportation in urban as well as rural areas, which is advanced than the current conventional vehicles.
The proper system using the technique of reinforcement learning can be considered as energy efficient. The system can be more useful in the future when there is high demand for electric vehicles because of the lack of fossil fuel.
We have successfully completed the simulation of a 3D motorcycle prototype, and the simulation results showed that the model was able to balance and move in the created environment with the required packages. The test results of simulation proved that our final prototype was successfully trained to balance any terrain even to a slope.
Normal people can use this application to minimize the risk of road accidents due to the loss of balance when braking or stopping suddenly in traffic. This application will also benefit in stabilizing the bike without any need of human help externally.
Thank you.